All right. So we are moving into the glory that is more than 90. So when we are doing trig ratios, SOHCAHTOA, they are only usable for 90-degree triangles. And of course, they're usable all the way around the circle, but you still need a 90-degree triangle for them to work. Do we all understand this? Right? No matter what, you need a 90-degree triangle. So don't write this down. Just look at what is going on. If I gave you this, and I told you this side was 12 and this side was 17. And I told you I wanted you to tell me how long this side was, what would you do? Don't do it. Just what would you do with that? Could you do it right now? How? What would you have to do?
I was like, why isn't Talvin saying anything?
How could you do Pythagoras?
You would square both of those.
Really? Look at it again. Why can you not do Pythagoras? There's no 90 degrees. So Pythagoras is out the window. So I'll ask again, can you do this as it is drawn right now? Do you have the mathematical chops to do that? You do. You absolutely do. Okay, now talk to your neighbor. Figure it out. Don't do it. Tell me what you would do to be able to tell me how long x is. Duncan. Of course you would, Duncan. You draw this line right there, and you would use cos over here to find this, and then you would use cos over here to find this, and then a plus b would give you x. Right? Nice job, Duncan. You still don't what? You draw a line, and that makes two 90 degrees. Yeah. Then you have this 90-degree triangle with a theta of 37, an hypotenuse of 12, and an adjacent of A. Then over here, you have this 90-degree triangle with a theta of 23, an adjacent of B, and a hypotenuse of 17. Then you would know A and B, and you would add them together. Blech! Takes forever. You guys aren't stupid. If there's one thing that math people are, it's lazy. And they don't want to do extra math. So of course they worked out a way to deal with this. Now again, I don't want you to write this down. I want you to pay attention to it. Okay? Is everybody cool? Watch. I'm going to draw this a similar thing. Okay, I'm going to give this an angle. I'm going to call that angle, I'm going to make him 60. I'm going to make this guy 25. Cool? All right. I'm going to make this guy 18. I'm going to make this guy 24. Is everyone all right with this? Okay. Now, I want you to watch. Please watch and follow the thinking. Do not write it down. Do not talk to anybody. Watch and follow this thinking, okay? Because there's a logic step in here that you need to be aware of that will come in very handy in future math classes, all right? Now, if we were going to solve this, as Duncan says, we're going to drop this line down here, yes? Are we cool with that? Now, I have made two different sides, haven't I? Two different triangles now, yes? Okay. I'm going to go ahead and call this right here. I'm going to do something weird that you guys aren't going to like, but I'm going to call this H for height, not HYP for hypotenuse, because that's the height of the triangle. Is everybody cool? Because in triangles we use height, right? Base times height is the area. Everybody good? Okay. Now, please watch this. In this triangle, what over here, and I'm going to highlight it in green, what trig could we do with this triangle right now? SOHCAHTOA, but which part of SOHCAHTOA? Sine. We can do sine with the green, can't we? Why? Because we have a theta of 60, we have an opposite that is h, and we have an hypotenuse, which is 18. Cool? So what would this look like when we wrote it out? What would we write? Sine 60 equals what? H over 18, yes? And that's not how we would leave it, is it? We would multiply both sides by 18 and we would get 18 sine 60 equals H, wouldn't we? Is everybody good? Yes? Okay. Now, over here in this purple triangle, what math can I do? Do I have a theta? What is it? 25. Do I have an opposite? What is it? H. Do I have an hypotenuse? 24. Is everybody cool with that? So what would this look like? Sine 25 equals H over 24. And what would we do with that? 24 sine 25 equals H. Now right here we have the logic step that causes much grief for everyone. If this equals H and this equals H, then what do we know about these two? They are equal. Do you all understand that? That piece of logic, for some reason, so simple to see, people don't get it. And it's so important in math that you understand. If A equals B and B equals C, then A equals C. Do you understand that piece of logic? No matter what it looks like. Okay? So this tells us that 18 sine 60 must equal 24 sine 25. Does everyone agree with that? Yeah? Okay. Now, please look at this. Forget the purple and the green now. Where do you see 60 and what's related to 60? I have an adjacent to 60 and I have an opposite to 60, yes? And 25, I have an adjacent to 25 and I have an opposite, yes? Everyone cool with that? All right. Now we are working with the sine law right now, yes? Sine uses what side of the triangle? Opposite. Okay? So that must mean, through logic, we know that sine 60 is related somehow to both 18 and to 24, yes? Because of that equal sign. Everybody cool with that? And we know that 25 must be related somehow to 18 and 24, yes? Okay, so if I were to do the following, if I were to take out any one of these values, we would do algebra, wouldn't we? And to do that algebra, we'd have to do some dividing, yes? If we didn't know this guy, we would divide both sides by 18, wouldn't we? If I didn't know this guy, we'd divide both sides by 25. If I didn't know this guy, we would do algebra, yes? When we do that algebra, we find the following. Sine 60, if I divide by 24 there, to get rid of that 24, what do I have to do to this side? Divide by 24, correct? If I were to, what would I do to this side to get rid of the 18? Divide by 18. So if I do that to that side, what do I got to do to this side? Divide by 18. So sine 25 over 18. So this second thing I have done must be the exact same thing as this, according to algebra, correct? Because if I divide this side, both sides by 18, what happens to that 18? It goes away, and I get an 18 over here. Cool? And if I divide this side by 24 to get rid of that, I got to divide this side, but I've already got rid of the 18, so I get that. Does everybody see? Okay, so what does that tell you the third side is going to be? This is angle C, and this would be side little c, right? Because it's across from C. What do we know about the third one? If sine of that guy over that, sine of that guy over that, what's the third one going to be? Sine C over, what would be down here? Look at the triangle, guys. What would go right here? Little c. That's it. Now, do we know this value? Do we know big C? Yeah, we do. How? It's 180 minus 85, isn't it? 60 and 25 makes 85, 180 degrees in a triangle. So we know this is 95, don't we? So what could I put in for C? 95. And now I can find the third side. How? What math works that? We used it a ton in our conversions unit. I even gave you a little rhyme to remember how to do them when it's fractions equal fractions. Don't worry about it. We'll do it right now. This is what we're about to do, and this is why it works. Okay? Does everybody see? I didn't want you to write it down because you guys get trapped in writing it down and not understanding what is going on. You all understood drop the H. You all understood the algebra we did, yes? So that leads us to where we actually are in our notes, which is the sine law. And the sine law states this. You can also write it as with the signs on top. They are all the same thing. When I learnt it, we put the signs in the numerator and we put the sides in the denominator. Lately, textbooks have flipped it around, but it's the exact same thing as long as it continues through. All right? This is the law. You have been shown why it works. So now all you got to do is use it. Okay? So let's draw a triangle. Just draw one. Doesn't matter what it looks like. And label it A, B, C. What is this side going to be? Little c. What is this side going to be? Little a. And what is this side going to be? Little b. Now, as long as you have numbers in there, you can fill this in. Does everybody understand? Okay, I showed you right here why it works. Do you wish to see that again? With letters instead of numbers. Do you want to see how we get to here from here, or do you understand? You would drop down this, which would be H, right? And then sine of big A, which I'm going to color in red, right, equals H over C. Cool? Everybody okay with that? Right? So C sine A equals H. Is everybody good? You have to stop me if you don't get it. Everybody sees that? Okay. Now over here, sine C equals H over A, doesn't it? Is everybody okay with that? So that means H must also equal A sine C, correct? Yeah? Which means, what can I do with these two H's now? Take them away, because if these both equal H, then they equal each other. Cool? Now, I don't like this, so I'm going to divide this side by C to get rid of that C. Cool? If I divide this side, what do I got to do this side? Divide it by C. Everybody agree? Okay. Now they're going to cancel. And now I've got sine A all by itself, right? Now, what over here don't I like? I don't like that A. How am I going to get rid of it? Going to divide by A, and what's going to happen there? They're going to cancel, but I got to divide this side by A. And there is my nice, pretty sine A with its side and sine C with its side. And once it works once in the triangle, where else will it work? With the third one. Is everybody cool? Tavleen?
Do you want to understand this? Well, are we going to have to show like all that work on it?
No, of course not. This is proving it. This is how the law was devised. The reason I show that to you is because sometimes you don't just get to plug stuff in, right? You need to know how we got to it. All right, so everyone's good? Everyone gets the algebra? We can attack a question or two? Okay, before we go on, there's a couple of things you got to be aware of. These are those things. 1, largest side is always opposite the largest angle. Now, but we know that from right angle triangles, don't we? What's the biggest angle in a right angle triangle? The right angle, it's 90. And the hypotenuse is the longest side, right? What's across from the smallest angle? The smallest side. What's across from the middle angle? The middle side. So you got to remember that, okay? That will really help. And you got to remember, what does opposite mean? What does opposite mean in trig? Straight across the triangle. Okay? So, let's begin with this first one that's nice and easy. I have triangle ABC, and I know two of the angles, 40 and 75, yes? So I'm going to draw them. I'm going to draw my triangle. Which one of those, the way I've drawn it, has to be 40? The one on the right or the one on the left? The way I've drawn it. Neither one of them is going to be 40, but which one of them would be 40? On the right or on the left? Which of those is a steeper angle? Left or right? The right is a steeper angle? This is where 40 has to be the way I've drawn it, doesn't it? Because it's obviously smaller than here. Oh, that's your right. It's my right. Yeah. Okay. So this is 40. Yes? So if this is 40, then what letter would go here? A. That makes this what? 75. And then it's B. Everybody cool? Which makes this side what? C. AB is 6 centimeters. Everybody understand? Okay. Now, can I use the sine law? The sine law says, right here, I need an angle and the side that's across from it. Do I have an angle? Yes. Do I have a side that's across from it? I do. Do I have a value there? No, so I can't use this guy. Do I have this? Do I have an angle? Do I have a side that's across from it? No, so I can't use this guy. Do I know this angle? How do I know this angle? This angle is 180 minus what? Minus 115, isn't it? Which is 65. So now, since I know this is 65 degrees, do I have a pair? So can I do the work? Does it matter what I put in the numerator, the sign or the number? Doesn't even matter. Okay? So I'm going to go ahead and I'm going to write it the way you guys have in your notes with the side in the numerator. So it would be 6 over what? Sine 65, right? And that would equal this side right here. What would this side's name be? BC or little a, yes? I'm going to name him little a. So it would be little a over what? Sine 40. And what would the third one be? Little b over sine 75. Cool? Now you do this all in one go on your calculator. You set it up this way with your known one first. Everybody cool? Now, who remembers the fun little rhyme? Tavleen? No, that's not a rhyme. In today's rap hip-hop world, even that is not a rhyme. It is multiply the pair and divide the spare.
Oh, I remember that.
Where is the pair? Where is the pair? 6 and sine 40. Where is the spare? Sine 65. So on your calculator, what are you going to punch in here? I'll get my calculator up and ready to go. What do I have to make sure with my calculator before I go on? That it's in what mode? Mode degree. I'm in the mode degree. So, I got to multiply the pair. 6 times sine 40, yes? 6 times sine 40. I have a forward calculator, correct? And that's going to get me A. What's A? 3.856, so 3.9, yes? Everyone agree? So A equals 3.9. I'm going to write that right over here. 3.9. Everybody cool? Now, I said we're going to do this all in one shot. There's my answer for A, yes? So that's got to multiply by what? Sine 75. So I have that right there times sine 75. Oh, crap. I'm such a doughhead. What did I forget to do? I only multiplied. I forgot to divide the spare. Durr. Rewind. Multiply the pair, divide the spare. So you take 6 times sine 40. 6 times sine 40. And then what? Divided by what? Sine 65. And that gets me 4.3. Cool? So that means that A is 4.3. Yeah? Is everybody good? Now, I know that A is 4.3. I've got it right on my calculator, don't I? So that's got to multiply by what? Sine 75. And then divide by what? Sine 40. And that gets me 6.4. Now, let's check. Is 75 our biggest angle? Is it across from our biggest side? Yes. Is 40 our smallest angle? Is it across from our smallest side? Is 65 our middle angle? Is it across from our middle side? Yes. So we know we did it right. Now, what if I have a backwards calculator? No difference. You just punch in 6 times 40 sine divided by 65 sine equals. Okay? Is everybody good? Jenna, don't be that way. You don't. It's your first day you've seen this. There is, today and today only, there are no stupid questions.
Okay. How do you, know that you're okay?
Oh, I've got coffee all over myself. I've forgotten how to drink.
Okay.
Carry on.
I'm not
Now this is stupid. Your question is fine. Mr. Myers, I'd like to talk about trigonometry. Blah. Jenna, I'd like to talk about teaching me how to drink out of a cup.
okay.
See it? See the difference?
Yes.
I'm stupid. You're not.
Okay, I feel better now. How do you, like you said, multiply the pair? Like, how do you know what the pair is?
Okay.
Like,
Okay. So this harkens back to old-fashioned algebra. X over 7 equals 14. Oh, I lie. 15 over 21. Solve that. Properly. No shortcuts. What's your job here? To get x by itself, yes? So what do you have to do to this side? Multiply by 7. Right? Cancel. X equals 15 over 21 times 7. Yeah? Okay, good. Next. X over 9 equals 27 over 3. Solve that. multiply by 9. So you're cool with getting that alone, right? All right. Now, solve that. You still multiply by 9, right? Okay. So now, solve for x. Get x alone. Multiply by y, right? And I've got x equals ay over b, correct? Okay. You're good with letters? All right. So now we have to go to put it all together. No. Yep. Solve for x. I know. Trust me, it's easy. What do? Multiply by 14 because it's the same, right? Okay. Now solve for x. Is x allowed to be in the denominator? I don't want x. I don't want 1 over x. I want x. So how do I get x out of there? See, this is why I did all the other ones. When it was this, what did you do? You multiplied by 14, right? Okay, because x was already up there. So what do? What was it here, 15? So what do you do? Oh, it was 15 over x, wasn't it? So what do you do there to get that x out of there?
Do you want me to say it?
No, I don't. Okay, Jenna. What do you do there? Why? So it cancels this 14. It moves that 14 out of the equation, yes? Because you don't want that 14 in the denominator, do you? Okay. So what should you do now? Do you want that x in the denominator? No. So what should you do to get rid of it? No. Multiply by x. Just stop. What do you get to do now? Yeah, but that's not solving for x, is it? So what did I do to this side? I multiply by x. So what do I got to do to this side? Multiply by x. Now I have 3x over 7 equals 15, yes? Now how do I get rid of that 7? Multiply by 7, right? So now I get 7. They're going to cancel, and I get 3x equals 15 times 7, which is 105, yeah? Now what do you do to solve that? Divide by 3. Now go back to the original question. I multiplied by 7, right? And I divided by 3, didn't I? Okay. So multiply the pair, 7 times 15, which I did. 7 times 15 got me 105. Divide the spare.
I wasn't the only one that didn't get that.
Apparently not. So, what we are doing now multiply the pair. There. Divide the spare. The pair is whatever diagonal pair you have. Okay. It is nice to know, and I only did show it to you like 6 times in the first unit. Unfortunately, I keep video record of this, so there's no need to go back and prove it. So back to our notes. So let's look at the next one. I have a new triangle. Solve triangle DEF. What does this verb solve mean? What does solving a triangle mean? Right. Means find all sides and angles. Okay? So now, look at our information. We're doing a trig question, aren't we? So what do we need? A triangle. What do we know about this triangle right now? It's got one angle of 35, yes? So if I draw a 35, does it matter how I draw it? Not even a little. That's 35, and I know that's D. What else do I know? Little d is 7. Where's little d got to be? It's got to be across from big D, so that's 7, correct? Do the other two matter? Does it matter which one I make E and F? Not even a little, does it? Doesn't matter at all. If I make that E, then how long is this side? 12. Why, Emma? Because it's little e, and little e is across from big E, yes? And if I make that D, then what's this? Big F, which makes this side what? Little f. Everyone okay? Now, am I allowed to use the sine law here? Yes or no? I am. Why? Because I have that pair, don't I? So I'm going to write the one I know. 7 over sine 35. Now, what does that equal? 12 over what? Sine what? Sine E. And what's this one? F over what? Sine F. Now, here is where your knowledge comes into play. Which of these can I do right now? Can I do anything with this guy? Yes or no? Yes. Why? Because I have a pair and a spare to divide. Can I do anything here? No. Why? Because we have two unknowns. But once we know sine E, do we know angle E? How? Once we know a sine of E, how do we find the angle? Shift sine. And once we know E, do we know F? How? 180 minus. Okay? So, how do we punch this into our calculator? Now, I remind you, I don't like going to my calculator until the end of a trig question. So this right here is going to be 12 sine 35 divided by 7. That's going to get me what? That is going to get me sine E. But I don't want sine E, do I? I need E, don't I? Right? So once I get that, I need to do shift sine E there to get my answer. Now, can I do that all in one shot on my calculator? I can, because all I need to do is this. If I write this out, watch what I can do. You guys are probably all going to do this. You're going to go, and this is okay, there's nothing wrong with it. You're going to go 12 times sine 35 I have to close my brackets, right? Then I have to hit equals. Then I have to do divided by 7. If I put brackets around everything, I wouldn't have had to hit equals. Everybody cool? So everybody got 0.983, right? Then I would need to go shift, sine, and for my calculator, I got to go second answer, enter. And I get 79.5 degrees. Cool? Everybody should have gotten that. Yes? Now, if you get slick with this, and by saying slick I mean good, you can do it all in one shot, right? I know I need an angle, yes? Right? So since I know I need an angle, I'm going to go shift sine right away, and then I'm going to put this in. Because I know this whole thing needs to be shift signed, doesn't it? So when I get good with my calculator, I can do this. Shift sine. Now I'm going to put another bracket. So 12 sine 35 stays together. See that? 12 sine 35 is all together. And I'm dividing that by 7. And then I'm closing a bracket to have kept it all together. Then enter. 79.5. What is the skill here? Is the skill the calculator work, or is the skill the paperwork? Paperwork. This is what I need you to be able to do. You can shorten your work and lighten your workload if you learn how to use your calculator. But do you get the answer any better? No, it's the same answer. Okay? So don't stress. If I use my calculator in a different way than you, is that okay? Yeah. So now that I know E is 79.5, I have it right on my calculator there, don't I? So over here, since I know E is 79.5, I can put 79.5 right in there, can't I? Or in my triangle right there, yes? So once I know that this is 79.5, would I leave that as 79.5? What would I round that to? Because it's angles. 80. Good. Oh, I erased a line of my triangle. 80, which makes 80 and 35 what? 115, yes? Which means this guy is 65, yeah? So now, can I do this? I can, can't I? Because this guy, we know, is 0.98, yeah? Or whatever it was. Doesn't matter. We're going to say sine 80 equals F over sine what? 65. Now, I need a side. Am I going to need to do any shifting? Do I need shift sine at all? Nope. What do I punch into my calculator here? Multiply the pair. Where's the pair, Jenna? Right. 12 sine 65, and what am I dividing by? Sine 80 to get F. Everybody cool? And what do you get? 11 point something? I choose to believe you. 11.74, I think I heard. 11.04, so 11. Now let's check. 80, 12. Biggest angle across from biggest side? Littlest angle across from littlest side? Middle angle across from middle side? So did I do it right? Would it matter if I had changed F and E? Of course not. Our triangle would have looked weird, but we would have had the right values, right? So you guys, I want you, now right away, as soon as you see the title of the next page, ambiguous triangles. What does ambiguous mean? Do you know what ambiguous means? It's very hard to explain. Its definition is ambiguous. What does it mean if there's ambiguity in something? I know it's not English class, but what does it mean if something has ambiguity? Okay, let's try an experiment. It's not racist, so don't get mad. What continent do you think this actor is from? Christopher Lee. What continent do you think he is from? Asia. Why? Because his last name's Lee. But his first name is Christopher. Right? Okay. Everybody is cool with this? Is that an Asian man? No. That's Saruman from Lord of the Rings. Pretty white-looking dude, yeah? Yes, he's tan because he's an actor and he doesn't have to spend any time where it rains 300 days a year. So, where was the ambiguity there? You assumed that he was Asian because of the name Lee, yes? That is ambiguous. Everybody with me? We thought, oh, okay, well, it had to be that. Right? He has to be from Asia because his name's Lee. Everybody understand? When I was in grade 9, I had a super crush on a girl named Raina Lee. Wasn't Asian. But I also had a super crush on a girl named Sylvia Lee. She was Asian. Cool? Okay. So, ambiguity means you don't know. All right? Everybody cool? All right, so let's have a look at this triangle right here. Let's draw a triangle ABC. So I'm going to draw the angle first. It's 30 degrees. Cool? All right. Now, I have AB is 6 and BC is 4. Yes? So one of these corners is B and one is C. Agreed? Do we know which is which? No, we don't. So let's go ahead and draw B and C, which would mean I would now connect this. Is everybody cool? How long is AB? 6. Right there, yeah? How long is BC? 4. Okay. Everybody cool with that? Now, can I do the sine law here? Look closely. Jenna says I can. Jenna, why do you say I can? I have an angle. I have a pair right there, don't I? Yes? And I don't have one there and I don't have one there, do I? Okay, is everybody cool with that? So I can go ahead and sine law this, can't I? So it would be 4 over what? Sine 30, right? Would have to equal what? 6 over sine C. Is that cool? Okay. So multiply the pair. It's going to be 6 sine 30 over 4 will get me sine C, yes? And then I would have to shift sign, wouldn't I? So let's do that with our calculators and tell me what you get. What do you get? 48.6, which would be 49 degrees. Cool? Everyone agree? Yeah? Okay. Now, once we do that, we could find this side and we could sign for there, correct?
Would it matter? Because you said like the whole, like the big angle, small angle, big angle. Would it matter what side it's on?
We're about to discuss that. That's where the ambiguity comes in. It's a good question, Emma. You're actually ahead of the curve. So now we know what this side is now, right? Right? It's 101, agreed? So this side's 101, yes? Yes? So that means this 4 sine 30 works with little b and sine 101, correct? Everyone agrees with me there? So what's that going to be on our calculator? Multiply the pair, 4 sine 101 divided by sine 30 will get me b. $7.85 or 7.9. Everyone cool? Does it work? Are we happy? Do I have the biggest angle across from the biggest side? Yeah? Why do you look confused? 4 times sine 101 divided by sine 30 equals. Are you sorted, Karina? Is it working? Did you get 7.9? Okay. Everybody cool? So that one worked, yes? Okay. Notice how I'm leaving a bunch of white space here. Please try and follow me along with this. Now let's draw this one. Here's my 30. A, B, C. AB is 6. BC is 3 now. Everybody cool with that? Yeah? Okay. Can I do the sine law? Yes or no? Sure I can, because I got a pair, right? So this one is going to be sine, oops, sorry, I put the sine first. 3 over sine 30 must equal 6 over sine C, correct? So now you tell me what C is. And you're going to get a weird number. What is it? Okay, that's the sine. So what's the last step? Shift sign. So it's what? 90. Wait a minute. 90? We could have done regular SOHCAHTOA. Why did I put this here? To prove to you can do sine law anytime. Is everybody cool with this? Everybody is good? Is everybody good? It's normal, yes? Please leave this big white space. Everyone is good? I don't care about the other one. Because what's the other one have to be? 60, right? We're going to leave it alone. Now let's look at number 5. Draw it. 30. B, C. AB equals 6. And this is 2. Do you need to do any work? Or not do you need? Can you do any work? Really? Look at number 4. How long was AB? 6. Look at number 5. How long was AB? 6. Excellent. How big was angle A? 30. How big is angle A? 30. How long was the third side in number 4? 3. How long is this side? 2. Can it possibly reach? Really, guys? All right, then we got to do this. I was hoping you'd see it. What's 2 over sine 30, yes? And this one is 6 over sine C, correct? Do that now. What do you get? What does C have to be if that's 6 and that's 30? You just did this question on number 4. It has to be what? That will give us a 90-degree angle, right? Okay, what do we get for C here? So what do you get? Of course it's his error. Why? You can't have a sine bigger than 1, can you? So this triangle can't exist, can it? And I thought you'd figured it out. Because you were like, got it. Guys, look. The last triangle you did was this. 6, 3, 30, correct? Well, and that gave us a 90 degree, right? This side had to be 3, didn't it? If this is 30. Well, in this one, this is 30 still. This is 6. But this is only 2. Does it reach? Can it make a triangle? Can it? No. Right? Everybody cool? Don't worry, we're going to do more with this. We're going to stop after we do the right, just do the work for 6. So what's 30? I'm not giving you any math homework tonight. I'm leaving you alone. 30. This is 6, right? Notice how I've always kept 6, because the triangles are always the same at the beginning, right? AB is 6. Now, BC is 8. All right, everybody cool? Now, so this is 8, right? So what is I have 8 sine 30 equals 6 over sine C. So what's C? What's C? $22. Everybody agree? Now, here we're going to start using our white space. Everybody cool? If I was going to draw this, it would have to look like this. 30, 22, because the 22 is a little angle, isn't it? And how big would this guy be? $128. Does everyone agree? Everybody cool with that? That triangle works, doesn't it? Yeah? Okay. Now, could I also, though, what time is it? Do I want to go on with this? I hear you. I know. No, we are going to do it. We're going to do it. Everybody cool with that drawing? Everyone's cool with that drawing? Okay. Now, I want you to go back up to the first bit of white space you left. Question 3, yep. Um, 6:30. And I want you to change the order here. I want you to make that C and that B. Would that change anything? Why, Shotzi? Because those two are the only ones that change. This still has to be 4, doesn't it? We know it has to be 4, yes? Everybody cool? Even if they switch. Everybody good? Okay. Now, in this one, change it. Does that change it? No, because it's still going to be 3. It had to be a 90-degree triangle, right? Everybody cool? Okay. This one. Did that change it? Of course not. This is still 2. It's still not going to reach. There's no triangle that could have this. Right? Okay, now. ABC, right? This is what it would have to look like, correct? Change this to CB. Does it change now? Is this side still going to be 8? Doesn't change at all, does it? Is everybody cool up to there? Because up until there, everything works normally, right? No matter what we do with B and C. Is everybody cool with that? So up until here, has there been any ambiguity? No. The triangles have to be the way they are. Is everybody good with that? Okay. Everyone is good? 100%? Doesn't matter what I do with B and C? We know what the triangles are going to look like, don't we? What was it that made it so? It was always the third side, yes? Right? Now, how long, and I'm going to erase, no, I'm going to go right here. How long is this blue line? I went straight from the top right down to the bottom and I made a 90 degree. How long is that blue line? We already know this from number 4. Not number 4. Yeah, number 4. How long does that blue line have to be? Has to be 3, doesn't it? Right? And if this side is 4, where else could it go? Could I draw this 4 in here? Yes or no? Because you all told me there was no ambiguity. But look closely at this. Did I change that 30? Could that 4 be on either side? Which means could I have this triangle? 30 with a 4 there. Or this triangle. Do you know which one I have? Do you know which one? Do you see why this is possible? Because this 4, it's bigger than 3, isn't it? So it can swing both sides like a pendulum. Do you all see that? There is the ambiguity. You all told me there was no ambiguity. But it makes sense that there is, isn't it? Let me show you what I mean. Where's my big metal ruler? There is the 3. Is everybody happy with that? There is my 90 degree. Agreed? Pretend the white ruler ends right there. Cool? Everybody understand? No. Can't do it that way. I'm gonna need a volunteer. Okay, come here. There is our 6. Everybody understand? Hold that up right there. That's our 6. Cool? Now I need a slightly shorter ruler. Who's got one of those little rulers? Just like a regular ruler. Hand it over. Yeah. Yes. Throw it. Everybody cool? That's our 6? Right? This is our 4. Understand? So we know it could go out here. Put your arm down there, please, Lauren. And I can make that triangle, yes? That's the very first triangle we made. Everyone agree? 6, 34. Yes?
Yeah. Because to us, the 6 is going this way, and that's going this way.
Go around to the other side of me.
Yes.
6, 34. Yes? Okay. Now, how tall, this angle in here, this has to be 3, correct? So now watch. Remember, the angle by her knuckles is 30. Watch. See how I can still make the triangle? Because this swings and will eventually make the triangle again inside here, never affecting the 30 or the 6. Does everybody see that? Now, if it's 3, it can only make the 90 degree, right? Because if it moves at all, it's no longer going to be 90, right? If it's 2, it never reaches, does it? Can't make a triangle at all. But the last one, it was a big one, wasn't it? It was bigger than 6, yes? So, if I make this guy, which is bigger than 6, does everyone agree? Hold that up. There's my 6. If I swing this way, do I make a triangle? No, because it goes too far, doesn't it? So it has to swing all the way out and make the giant triangle. Does everybody understand? So the only time it's a problem is if the third side is smaller than this, but bigger than your height. Then there's 2 choices. Does everybody see that? Okay? That's where the ambiguity lies. So you have to check. You check the height of the fake triangle by using sine. You find that to be 3. Now, if your other side is 4, it could be, and this was 6, since 4 is bigger than 3 but less than 6, it could be on both sides. Does everybody understand? If it's bigger than 6, then it has to go way out here. Because if you swung this down here, you wouldn't make a triangle, would you? If it's exactly 3, it's going to make a 90. If it's less than 3, it's just going to swing in the breeze. That's your work for today. We'll come back to the rest when you get back.